My name is Steve Boger from EPT, and I'm here to demonstrate the installation and operation of our SVR, or soluble varnish removal technology. Here we have our SVR 1200. We do have other models that are sized according to the reservoir. Upon receiving your SVR, first thing you want to do is connect the system to your reservoir via the inlet and outlet valves. On some units, the inlet valve will be smaller. It'll be 1 inch, as according to the 1.5 inch seen here. All SVRs are comprised of 2 technologies. Larger vessel, containing our ICB, or ion charge bonding filters, that remove the soluble contamination from fluids. The second, smaller vessel, contains a high efficiency mechanical filter to remove any solid particulates. Before starting your unit, ensure all of your valves are in their correct position. For any valves on the inlet and outlet lines, ensure they are open. Ensure V2, or the ICB inlet valve, is closed. Ensure V3, or the ICB bypass valve, is all the way open. And ensure V4, or the drain valve, is all the way closed. Next, you're going to start the units using the starter box in the front of the unit. After your mechanical vessel is filled, you can bleed any residual air using the valve located at the top. When you're ready to start flowing oil through the ICB filters, simply open up V2, or the ICB inlet valve, and you can regulate the flow going into the vessel with the ICB bypass valve. Ideal flow for the ICB vessel is between 4 and 5 gallons per minute. Once you've flooded the vessel, it's critical that you remove any air from the top of the vessel using the bleed valve so that you have oil flowing through both filters. During normal operation, expect to see pressure in the ICB vessel of between 20 and 25 psi. This can vary depending on fluid quality or temperature. If at any time you need to drain the ICB vessel for changing filters or for shutting the unit down, simply close the ICB inlet valve, open the ICB drain valve, and open up V3, or the bypass valve. This will allow the fluid to drain from the vessel, and you can change the filters. Anytime you need to stop the unit, simply turn off power at the front. Thank you. For more detailed information, please see the installation guide that was included with your unit.
Good afternoon, my name is Peter Dufresne, I work with EPT. Today what I wanted to show you about was how our TMR N2 product works. TMR N2 is a small nitrogen generator that runs off a normal compressed air source, and the membrane itself is here. And with a regular compressed air source set at 100 psi, this essentially splits the compressed air into 2 streams, high purity nitrogen and enriched oxygen that's discharged there. We take the high purity nitrogen and we vent it, we direct it on top of the lube oil system, and it offers extraordinary benefits to the quality and protection of that oil. Our inlet here is connected, and this regulator is set at 100 psi. That compressed air is directed into these 2 pre-filters, and the point of these pre-filters is to remove the particulate, but more importantly, any residual oil that's in the compressed air. Residual oil in the compressed air would be one situation that would reduce the life expectancy of this membrane. This membrane should last 10 years, provided that these filters are changed 1 time per year. So initially we connect this, 100 psi inlet pressure, our filters are installed, and this works immediately, and we basically set our flow. The flow requirements on nitrogen generating blanketing system are very, very low. We don't need a lot of nitrogen to remove the water that's in the oil. Most importantly, we want to protect the oil from contacting oxygen in the reservoir. But initially, we only need literally 5 liters per minute or less to remove the water that's in that oil. So we set this at about 5 liters per minute. It's sized to go up to 8 liters per minute, the system. It could be used at a higher rate, but that would just reduce the purity of the nitrogen. This configuration, this sizing, has been set to produce 98 to 99% pure nitrogen. For times when you need to get into the tank, in a nitrogen environment, there's health and safety requirements. Most importantly, nitrogen is a natural asphyxiant, so we can't inspect oil reservoirs without removing first the nitrogen that's in there. To do that, we can simply put the bypass on, and now we are producing just pure compressed air. So that pure compressed air now is being directed through the blanketing system at the same velocity. You could actually increase it if you wanted to, and after about 24 hours, that system would be completely evacuated of any residual nitrogen. I hope that's been helpful. If you have any more questions, please contact EPT for additional support. Thank you.